Hello. I was working on the intersection of AlienStor, BlueStor, and the SeaStor memory allocator. I think I found what were the differences between the DPCAS environment and my local machine. There were two of them. There were actually two problems. First one was about not initializing the memory allocator pools in our threads. This SeaStor allocator has two-stage initialization. It needs some assistance from the thread when willing to use it to overcome the 32 max in limitation level. Second thing is a bit is much more problematic actually. It turned out that our assumption that BlueStor, that RocksDB manages its threads in statical way using thread pools, it's violated. It has some consequences. I would like to discuss that after this step. That's me.
Tim?
I'm still working on replay. I noticed a better way of structuring the way the root node works, so I'm fixing that up today. Previously, I had a magic delta that set up that changed the location of the root node, but the entire root node is all of 16 bytes. So now the entire root node is in the magic delta, but I'm going through and cleaning up all the places where I did it the other way. This will be cleaner in the long run. The only things in the root node will ever be like 3 physical addresses. There's never going to be much there. That is, it'll have a pointer to the LBA tree root, a pointer to any other like allocator roots, and that's it. It's not going to have anything in it. So this is simpler, and it avoids having to write down an extra pretty much empty 4K page every time we need to roll over the journal.
So you're reusing the same physical page for the...
No, the root will just never get a physical page. Ever.
Okay.
Every time we roll the journal, we'll the first thing we write down will be or before we roll the journal, rather, the first thing we'll write down will be the new magic delta that contains the root node, the whole thing. If the delta always contains the entire node, you never actually have to read the node, right?
Okay.
It's the same thing I did before, right? There was a magic delta whose only contents was the location of the root.
So instead of relocate the root node, you actually
put the whole
write
root
a
node.
new copy of
No, I just put the whole root node in the magic delta, which means the magic delta, instead of containing one address, now contains like 2, because that's all the root node had in the first place. The real root node is the LBA root, which is a real B-tree node that really exists somewhere. That's something else. The reason for this node is that 1, you do need to bootstrap it, and 2, I expect we'll have a second allocator root for cleaning purposes that I haven't written yet. So there may be other top-level trees, or rather, exactly one additional top-level tree.
Okay.
It's no big deal. It's a minor change. It's just it simplifies a fair amount of code, so it should come out better.
Okay, sure. Thank you. Anything?
So I managed to clean up the logic to a better structure to be reviewable, and also extend this logic to all types of nodes, and also did some other necessary cleanups to proceed the implementation. And for Heartbeat, I did refactoring to introduce proper abstraction for review. That's me.
Thank you. I'll try to review it again this week.
Thank you.
Any comments or questions?
One question to Chumei. Are you able to run the I/O using the last two patches appended to the GIST? I mean the SeaStor and BlueStor.
I haven't tried it. I will try it later.
Okay. Thanks. So if we have some time, I would love to discuss the second, more fundamental issue with BlueStor now.
Sure.
I posted some in the last comment. I posted some description about possibilities we have in tackling this problem. But it's still pretty problematic, and I think I'm not sure whether we could. Okay, some background. As in my understanding, adopting BlueStor has two purposes, two goals. First one, the most fundamental one, is to provide testability of entire crimsoning topology. That's the primary goal. But there is also a secondary one. Free the SeaStor from handling in long term. In other words, not only testability, but production code, but production as well. And I'm not sure whether the productization is possible with SeaStor using with SeaStor in general, I think. Because if we switch to libc allocator, it's bad. If we use
Wait a minute. Why?
SeaStor allocator, 30% of performance off.
Yes, I know that part. I know that part. So I have said in the past that we should only compile one binary for both SeaStor and BlueStor. What if we relax that requirement? What if we said we get different?
Okay, that makes things different.
Okay, so I'm not saying
Yeah.
we should do it. Hang on. I'm not saying we should do it. I just want to point out that is the reason for that statement. We have previously given a fixed point that we must use the same binary, but if we relax that, then we can possibly do both. Okay, continue.
We have two goals, but addressing the second one, production with SeaStor allocator, is pretty problematic because BlueStor actually can start during its initialization, but still it can spawn as many threads as user wants. The situation got worse and actually got unveiled because of merging the BlueStor sharding PR on May 25th.
Wait, what do you mean as the user wants? Wait a minute. That's not right. The user can't create threads. Only we can.
Okay, that can be
User can steer the number of threads that is created in BlueStor by setting some configurables.
Yeah, we don't have to let them do that. We don't have to let them do that. We can set some configs out of bounds. That's literally always true with configs. Just so we're clear. Like if there are config values that aren't valid, we don't have to let them start the OSDs with those.
Yes, there is. My question was whether I wanted to ask is whether we need to have the same defaults for BlueStor running.
Absolutely not. Absolutely not.
Cool.
Yeah. No. Right now we're sharing all the config stuff, but at some point we're going to have to figure out what to do about that. It would surprise. I would be shocked if there were even that many config values that we want to default to the same thing. Like, I don't think this is going to be an exception.
Okay.
I think this is going to be really, really common. Yeah.
Okay. Because, well, sharding in BlueStor drastically increased the demand for threads created on initialization from,
Right.
let's say, 60 to 280.
I follow.
But if we can enforce users to not use the sharding or any other thing that leads to huge number of short-living threads created at initialization, then maybe we could use the SeaStor allocator even in production. Who knows? Definitely, it can be used for testing. It's even now. After merging the patches, it will be just a matter of enforcing one configurable steering the sharding to disable it. It will work. It should work. But there are also some clauses inside the SeaStor allocator itself. It was designed to handle pretty restricted scenarios, and for instance, it doesn't free the memory to underlying to the operating system. It's perfectly fine in a situation when you have statical threat management, like in vanilla SeaStor, like in let's say perfect RocksDB, that one that would use only statical thread pools, it wouldn't be a problem. But even if there is a big number of short-living threads, we need to be aware that the memory that was allocated just at the initialization stage, it won't be reclaimed. It won't be free to the operating system. Actually, it's not a fundamental limitation of the allocator. I think the situation is like that only because of legacy. Because that feature was unnecessary before merging the alien stuff in SeaStor. To actually tackle that pretty easily, and I think the patch would be mergeable with upstream. It's actually when a thread. There are some thread local control structures in SeaStor allocator. Now, when a thread exits, it actually does nothing except setting a one atomical boolean, nothing more. There is no call to madvice freeing staying to kernel. I don't need those pages. But it could actually we could actually bring that feature. The question is, I don't know at the moment whether it's worth the effort or not. It depends on how much of the memory would be taken at the initialization. I have no idea how it looks in real scenarios. It might be a problem, it might be not. I don't know. Just wanted to signal that maybe we would need to change the allocator itself.
Frederick, I just want to try to summarize the solution we have on the table. So the first one is to limit the upper bound of the thread we could use when RocksDB starts. I think we should have a lower upper bound if SeaStor is enabled when compiling Crimson OSD. So another option is to patch the SeaStor allocator, allowing it to reuse the statical structure, which is initialized when we a new thread is allocated, and it should be tax-free because in SeaStar, reactor threads do not exit, right? Practically, so it should be not big deal. When at least I don't think CLDB guys won't have a huge pushback because it's free, right? Because it's never get caught in a vanilla SeaStar
Exactly.
application.
The initialization in SeaStar and even in nicely behaving applications, POSIX applications that don't manage threads dynamically, is that it's actually the initialization can be handled by kernel itself. You don't need to worry. But actually, RocksDB, as we know from the debugging, it's not entirely a nicely behaving POSIX application.
Yeah. So that's the two options we have, right? And
there's a bunch of other, but they are more or less hacky. I don't see a nice, clean solution for that.
Thank you. Do you have a specific option in your mind which should be tweaked for smaller amount of threads, which is started by RocksDB?
Yes, I have. It's the one. It's actually the one that controls the sharding in BlueStor. It's, if I recall correctly, BlueStor RocksDB CF assign false. It's I think it's in the doc. I'm pretty sure it is in many places there. There are also other configurables we could tweak, like the number of thread pool for the AIO. By default, it's 16. We could minimize to 1. There is also RocksDB configurable for steering the number of the dynamically created threads for reading mem tables. By default, it's 16. We can pretty easily minimize it to 1.
Okay, I think probably the first step is to try to tweak these settings when with SeaStar is enabled or is defined, and if it helps, we can go that way. How about that?
How about not? There are many options. I think at the moment about 2 of them. One is to differentiate in our options.cc, which I'm not sure we want to proceed with. The second one would be to actually audit the configurables when SeaStor loads BlueStor, and just error an error to user if the config is improperly set. To make the stuff explicit. In other words, don't change defaults.
We'll have
validate
to do both.
Whether they are.
We're going to have to do both. But at the first step, we definitely have to validate, because if someone does something wrong, it shouldn't crash. They should get an error message. So that part's mandatory.
Exactly.
Later on, as we get closer to production, we'll change defaults.
Makes sense. Well, I'm not sure whether we will reach production.
Nevertheless,
it's open question. Yep, I bet there is a bunch of.
I feel like my statement stands on its own either way. As in, that's a thing we worry about when we get to production. It's not really about whether we do get there, right? It's that we don't really need it for testing.
Tautology will see. Tautology will show.
Okay.
Okay, so I'm going to turn the patches into a PR. I will add the validation in AlienStor and send that PR out.
If we come up with a safe range of the upper bound of the, for example, the thread number, we can add that setting to option.cc because we have that machinery in place already. So we can have a different fund for SeaStor Crimson and for classic OD. That would be a nicer way to solve it, I think.
Okay, nice.
And more user friendly that way.
Okay. If we still have some time, I would ask last question about the SeaStorized BlueStar. Actually, it might be. It definitely would overcome the problems with and I just wanted to ask what are the reasons why we well, I think I got the impression we don't prefer this approach.
I'm not sure we don't. I think we've had a world of trouble with trying to mix the conventional POSIX BlueStor with SeaStor. I think I like that approach in that it literally already exists and the SeaStor one doesn't, but that is the only advantage I see. So the real question is, how much work would it be to refactor BlueStor so that we can extract the threading and concurrency primitives? And I don't know. I don't know what the answer to that is. I feel like the answer can't be crazy. Like it just on some level can't be. But I could be wrong. Particularly given that we're totally fine with eating the whatever you call it, the thread API overhead. That's totally fine.
Do you mean the SeaStor threads?
Yes, I'm totally happy with eating that overhead. That
okay.
positively thrills me, in fact.
Okay. Well, my feeling is that the biggest problem is actually the risk. The risk we cannot qualify.
We can't quantify the risk with the current approach either. So while I agree with you,
But it exists.
It exists in both cases, dude. There's definitely risk in trying to jimmy the alligator.
I haven't meant the existence of risk. I meant the existence of Alienster. That's the game changer.
Oh, I see what you mean. Yes, except that it only kind of exists, right? Like we have a long way before we'd be able to productize it. A lot of auditing and testing. So that part's true either way. The only advantage we have here is that code exists. And it's not clear to me that that's really most of the work.
Yeah, tautology will show. By the way, Mark Nelson was considering yet another approach. Some kind of, but well, I'm not sure whether it's reasonable. The idea was to make a really dumb store, mostly for testing, mostly for validation, mostly for and possibly for spinners. But I'm not sure whether we want
to...
No,
writing a second simple implementation is way more work than he thinks it is. It's not a good idea.
Yeah, I asked Josh about NewStor, how long NewStor has taken, and it was about 2 years.
Right. Like, just NewStor on its own took a really long time. It's the transactions. That's the problem. Like, writing a transactionally correct object store is a lot of work, even doing it badly. Like, performance isn't even the issue. It's just that all of the work required to make sure you're failure atomic. I mean, yeah, it's work. There are no two ways about it. And we need it to be because that's how tautology works, right? That's a bell and whistle we can't do away with.
Exactly. Yep.
Moreover, that testing wouldn't actually test one of the biggest reasons tautology does failure testing is because it's doing it on an on-disk format customers will actually use or users will actually use. So if we're doing that testing on an on-disk format that will never see the light of day, that really reduces the value level. Not to zero, it's still valuable, but given how much work that store would take to write, I don't know. That's not an obvious win to me. There is a fourth option that is worth considering. We can create a write-along process with a simple IPC API, and I think we should consider doing that. That's what we're doing here, except for the minor detail that it will actually work and it will be simple.
Well, there would be one important difference. To compare with current AlienStor, in AlienStor, we don't actually copy nor modify the buffer list.
I know that. I get it. I also giantly don't care. Like, the amount that I care about copy overhead for a spinning disk is 0.
Okay, that's
Moreover,
nice.
There are smart ways to do POSIX APIs where you don't necessarily do the copy. But I don't really want to do that. That's like real work. You have to make sure the buffer lists show up in the right pool. You're basically doing RDMA at that point. So I don't think I care. I think the memory copy isn't a big deal. So I think we should consider that direction. Like with
but we could.
There are other advantages too, like that backend for BlueStore. If we do a good job, what we have essentially is an IPC-based object store protocol, which lets us test the object store independently against things like FIO without linking it into FIO, which is a big advantage. Like there are a lot of little side benefits from it. Let me put it that way.
Yeah, but that's also an option on the table.
Yeah.
Okay. Anyway, I will turn the branch with the patches for locator into a PR and add some new things about validation of the options.
Thank you, Rick. Looking into this issue. Anything else? Okay, thank you guys, and have a good one. See you next week.
Thanks, and see you later. Thanks for the discussion. Bye.